So like I said, we're really not extending, we're applying now. So the first thing we did yesterday was learn the trig derivatives. We learned what the derivative of sine was. We learned what the derivative of cosine was. We learned why the derivative of sine and cosine were what they were. We actually applied the proof of the definition of the derivative to each of those problems, and we determined what their answers were. So what we want to do today is kind of take that proof and apply it to real-world examples. So the first thing we're going to look at is harmonic motion. So a weight hanging from a string is stretched 5 units beyond its position at rest. So we have this weight, and it's just kind of hanging out. So here it is sitting in rest. And then what we do is we pull that spring so that essentially this weight is going to move up and down in this harmonic motion. So it's going to move so many units up and so many units down. The amount of units it's going to move relates to its position function right there. So we are told that the position function is S equals 5 cosine t. And think back to trigonometry. Think about what the cosine function looks like. So the cosine function kind of looks like that wave, right? So the cosine starts high, goes low, goes high again, goes low, etc. Well, that's what our position is represented by. This spring is going to go high, low, high, low, high, low. And then this line kind of acts like when the spring was at rest. How high it goes is directly related to the amplitude of the trig function. So what that means is that this is going to go up to a height of 5 and down to a height of -5 from its position at rest. So everybody good with what I've said so far? Kind of all logically makes sense, right? So what are the velocity and acceleration at any time t? Well, now we're so good, we can find velocity and acceleration by taking the derivative. The velocity is the derivative of position. So the derivative of cosine is negative sine. So velocity is negative 5 sine t. This should make sense. The cosine function is doing what from this point to that point? The little red dots. I know they're hard to see. Velocity, position is what? The graph is increasing, decreasing, concave up, concave down, what? Yep. It's decreasing. If position or original function is decreasing, my derivative is what? Negative. So doesn't this negative sign make sense? So sine usually starts at 0, 0 and goes up. But because it's negative, the sine function is going to start at 0, 0 Come on, undo button. There we go. The sine function is going to start at 0, 0 and go down. Do you notice anything about the black curve to the red curve? I'm going to zoom in on this for you. Anything. And I tried to do the best I could. I know it was a little off. Like my red curve should have maybe not been as low as it was. So let's draw that in one more time. I'll be even better. Yeah. Okay, so they're the same curve. One's shifted. 100% good. What else, Brooke? Exactly. Every time the black curve is at an extrema, the red curve is at 0. Every time position is at an extrema, velocity is 0. Why? Brooke? You nailed it with the end part right there. It changes direction. Changes direction. Every time the velocity is 0, the position of the spring is changing direction. Every time velocity is 0. So what that means is from here to here, my spring is maybe going to the left. Then from here to here, my spring is going to the right. So every time velocity is 0, the spring is changing direction. It might be going back up or it's going back down. Does that make sense? Like logically, because we're going to talk about that next week. More specifically, position, velocity, acceleration. That is Monday's lesson. So this is just kind of like an intro to it. Okay, and then acceleration is the derivative of velocity. Derivative of sine is cosine. That -5 is the constant or coefficient. Since the derivative of sine is a positive cosine, the acceleration will remain negative. So now the blue curve would actually be the black curve reflected. Look how pretty. Okay. Good? So then it says, what are its velocity and acceleration at time t? Describe its motion. So we have velocity, we have acceleration, we've described the motion verbally. Let's describe it algebraically. So in order to describe it algebraically, I need to know at what actual values, because these are general drawings, when is the velocity actually 0? When will negative 5 sine t equal 0? Okay, that's one value. Oh, sorry, I didn't hear you. Yes, at pi, good. And then this would continue on and on and on and on and on, right? It'll be at 0, it's going to be at pi, it's going to be at and 3 pi and 4 pi, etc. So it's going to be at any time t plus pi k, where k has to be what? K can't be any number in the world. It has to be in yep. So k has to be a positive integer. How often would the spring, what would the spring's period be? Like, how often would the black curve start and then be back at its starting point? What do we know about 5 cosine t's period? Like, when would one up, down, and back to up be? How long? Brooke? Perfect. So one full cycle is 2 pi. When would the spring be moving at the greatest velocity? So velocity is the red curve. When would the red curve be at its greatest point? When what? Brooke? What's passing through 0? Okay. Okay, when position is 0. That's what yes. I was trying to ask you, like, which curve you meant was at 0. Like, did you mean? Oh, no. When the red one is at 0, the weight's changing direction, which means it's at its -5 or 5. The velocity will be the greatest when the red curve is at a min or a max. So it will be when the black curve, which is position, is at 0. So the greatest speed or velocity will occur when position is 0. So the greatest speed or velocity would occur when position is at 0. So when would the position be at 0? 1 cosine 5t equals 0. So our t value is, what makes cosine 0? Thank you. Looks like we're due for a unit circle quiz. Good. So again, the speed or velocity will be the greatest when the cosine of t, 5 cosine t is equal to 0. So that would be at pi halves. Okay, when the red function is negative, the spring is moving to the left. When the red function is positive, the spring is moving to the right. Good. So I told you guys, equations of tangent lines and normal lines was never ever going away. Now we're looking at it in terms of other functions. So it says, find the equation for the lines that are tangent and normal to the graph of f of x equals 3 sine x at pi thirds. So I need to know, 1, what is f of pi thirds? So I need to know, okay, what's the sine of pi thirds? Times 3. Sine of pi thirds? Nope. Nope. Yup. Guys, I'd review your unit circle. Okay, so f of pi thirds is 3 square roots of 3 over 2. To get the equation of the tangent line, you needed the point. So our point is pi thirds comma 3 square roots of 3 over 2. I need the slope at that point. So slope is the derivative. So I need f prime of x. Derivative of sine is cosine. So the derivative of 3 sine x is 3 cosine x. And then I need the derivative of pi thirds. So it's 3 cosine pi thirds, which is 3 times a half. So the equation of the tangent line is y minus 3 square roots of 3 over 2 times 3 halves x minus pi thirds. And then the equation of the normal line your x and y stay the same. Your only change is the slope becomes the opposite reciprocal. So again, the derivative having a positive slope at pi thirds tells me that the graph was increasing on the original. So a positive slope tells me the graph is increasing on the original. Find the equation for the lines that are tangent and normal to the graph of f of x equals tan x over x at x equals 2. So once again, you need to know, okay, what is f of 2? Have no fear, tan 2 is not a unit circle value. So we're just going to leave it as tan 2 over 2. The derivative would need the quotient rule. So it's ho di minus hi d-ho all over ho-ho. That cannot be simplified. There's no identities for secant squared and tan. So you get 2 secant squared 2 minus tan 2 all over tan squared 2. Sorry, the denominator should just be x squared. I don't know why I wrote a tangent. And then I really don't like long fractions. So personally, I would say, okay, 2 over 4 is equal to 1/2 secant squared 2 minus 1/4 tan 2. And if this were a calculator problem, you would go to your calculator. You would make sure you are in radians, not degrees, because an x value equaling 2 is a radian value. An x value of 2 is somewhere between pi halves and pi, because pi halves is 1.571 and pi is 3.14. So a value of 2 is somewhere between them. So again, that should tell me right off the bat if this is somewhere between pi halves and pi, my tangent answer should be negative. Because in quadrant 2, tangent is negative. And that's all things we want to be thinking about. So if I'm thinking about the tangent being negative, the secant squared, so it's positive. A negative times a negative is a positive. This slope value is going to be positive, which once again tells me that the original f of x is increasing. So positive slope tells me the original graph is increasing. This one asks me for those tangent lines again. So it would be y minus tan 2 over 2 equals this 1/2 secant squared 2 minus 1/4 tan 2 times x minus 2. And then the normal line would be 1 over all of that. And honestly, you would probably just get a calculator out and find it. The reason I'm not doing this, oh, there's my calculator. This one was dead the other day, so I charged it. No, it's still dead because that one has no batteries. Okay, the only thing that's maybe slightly new from yesterday, besides equation of tangent lines and word problems, would be looking at multiple or higher order derivatives. So yesterday we only looked at y prime. So the derivative of secant is secant tan. The second derivative is now a product rule. So it's the first times derivative of the second plus the second times derivative of the first and then that gives me secant cubed x plus tan squared x secant x. So I could factor out a secant, and then that leaves secant squared plus tan squared. Anytime you have two trig functions squared and added, subtracted, multiplied together, you need to be thinking of your trig identities, because the trig identities come from Pythagorean theorem. Pythagorean theorem comes from squared values. So tangent squared plus 1 is secant squared. Therefore, secant squared plus tangent squared is -1. So the second derivative is negative secant x. The second derivative is negative secant. x. I know there's a little bit of space down at the bottom of your page. I just want to talk really quick in case it comes up, is that trig functions are cyclical. So like a linear function, the derivative of a linear function eventually zeroes out, and then the derivatives all become zero. A cubic function eventually zeroes out, and the derivatives become zero. Trig function derivatives go on and on and on forever. However, they're kind of like the powers of I. They start to repeat themselves. So after you take so many derivatives of a trig function, you get back to the beginning. So if we started with just sine x, the derivative of sine x is cosine x. The derivative of cosine is negative sine. The derivative of negative sine is negative cosine. The derivative of cosine is negative sine. So you'd end up with a negative sine, which gets me sine x, which is what I started with. So how many cycles are there? How many cycles are there going to be for trig functions? 4. Just something to keep in mind. Okay, your homework is not the last page in your packet. That last page you can like rip out and throw away. We can't do that till later. I didn't realize there were so many. So you can do the next page that says like the 3-5 trig review. It's that last page, has like the weird looking like circle with like 2 boxes on it. So you're going to take that page and throw it away, because I don't even want you to attempt it because you cannot do it. And then I have a new page for you, and that's how we're going to spend the rest of our time. Yep, because that one you can do. Those 8 problems are valid. It's just that last page. I originally thought I had whited out all the problems you couldn't do, but then when I was making my answer key, there are some chain rule problems on there that I missed, not realizing, and you cannot do chain rule.